This is the second video for solving absolute value inequalities, and now we're going to talk about when it's greater than. So notice that it says if the absolute value of x is greater than a, it's equivalent to x is less than negative a, or x is greater than a. So greater than, I like to say this, great or, maybe I don't want to circle that. I'll just underline the or part, great or. And that helps me remember what do I do with a greater than sign with absolute value inequalities, and this helps you get them set up correctly. Okay, so here's how we set this up. We take the absolute value part, the x minus 9. So x minus 9 is less than or equal to negative 2. Notice we have to switch two things. We have to make the greater than less than, and we have to change the sign of the number that's to the right of the inequality. And this is an or, and so then we say x minus 9 is greater than or equal to positive 2. So notice the second one looks just like it did, but with no absolute value bars. And the first one I have to switch the direction of the inequality and change the sign. Now we simply solve each one of these. So x is less than or equal to 7 by adding 9 to both sides, or x is greater than or equal to 11. And then we will graph that. Now, here's what it looks like on the graph, right? X is less than or equal to 7. So we're going to have a bracket at 7, and we are going to go to less than, right? X is less than 7, or x is greater than or equal to 11, right? So we're going to put the 11, and we're going in the greater than direction. And so we have that graphed. Now, we want to write the interval notation, which is, okay, two parts of it, right? We have this part starting at 7 and going in the negative direction. We have the part that starts at 11 and goes in the positive. And because it's or, we know that we have to write this compound or this inequality with a union, right? So we're going to have negative infinity to 7. All right, because that's where it, right? 7 to negative infinity. We write the negative infinity first because we always write this left to right. Union, a union symbol looks kind of like a U. And then 11 to infinity. And we did write some of these unions on the previous sections for section 2.4 or 2.5. I'm not sure which one or both. And so now we have our interval notation written. Okay, so you have to remember the difference between the less thans and the greater thans and how to set them up. And it's important that you practice this so you'll understand. All right, here's the next one. We're going to set it up initially, right? So we have our 4x minus 11 is less than a positive 1, or 4x minus 11 is greater than negative 1. Now, let's talk about that negative 1. This says that the absolute value is greater than negative 1, and I think you will agree that that's going to be true, right? No matter what, that's going to be true. That it will always be greater than negative 1 because it has to be positive, whatever comes out of that absolute value. And now we solve, so we're going to add 11. And so that's 4x is less than 12, or 4x is greater than 10. Divide by 4 to solve. So x is less than 3, or x is greater than, that's going to be 5/2 when we simplify that fraction. So less than 3 or greater than 5/2. Now, this is one of those ones that's going to be a little weird on the graphing it actually helps you write the interval notation. Because it's actually, no matter what we put in for x, it's always going to be greater than -1 if you can kind of help interpret that in your mind. And so x is less than 3. Okay, so let's put a 3 on here. And it's less than 3. Or x is greater than 5/2. Well, 5/2 is 2.5. Right? Let me put this on with a different color. All right, so we're going to say 5/2 or, right, or, and look what happens. They crisscross, right? They cross each other and they're just going opposite directions. And what this means is any value of x, right? So this actually means all real numbers. All real numbers are solutions to this because no matter what we put in for x, it's always going to be greater than -1. We show this as well on our graph. The graph is going to be everything. And so our interval notation, this represents all real numbers, right? Negative infinity to positive infinity. And I know that we've had some of those in previous lessons. Okay. So we have to follow that same rule about isolating the absolute value first. We're going to subtract 1. So that leaves us with the absolute value of 10 plus 3x is greater than +1. And then we're going to set that up 2 ways. And that's going to be this, right? So we're going to have 10 plus 3x is less than -1. Remember, reverse the inequality, change the sign. I like to write the or there to remember. It's a good idea that you do that. And then let's solve each equation, okay? So subtract 10. And then divide by 3. So x is less than -4. And then the next one, we're going to subtract 10 once again and divide by 3. Whoops, I don't know what happened there. Okay, it's doing something weird. Just a minute. All right, I had to fix my glitchy stuff there. And so we're dividing by 3. So x is greater than -3. Remember, this is an or. And then we're going to graph this on the, you know what I just did? I just realized what I just did here. Let me go back and erase. I subtracted, I got ahead of myself on the answer there. Okay, so I have to fix this. I was subtracting 10, not 11. So in my head I was thinking -11, right? -1 minus 10. So I have to fix this. So 3x is less than -11 because I wrote the 11 instead of the 10. You know, these are the things that happen sometimes, you guys. And then we divide by 3. And x is less than -11/3. I just looked at that and saw it as I was getting ready to write this over here. Let me write that in the blue to be more consistent here. Unfortunately, this just happens sometimes, you know, this silly stuff here. Okay, so let's get this graphed. It is less than -11/3, so you kind of have to think about that. Okay, -11/3 is actually -3 2/3. Okay, so it is going to be to the left of the -3, so -11/3, and it says it's less than, so we're going in this direction. And then greater than -3 will be to the right of that. And so we're going to write this as a union, right? And I guess I don't have to put, I'm going to scoot that over just a little bit so it doesn't look so close together there. It is fairly close together, you know, because they're just a distance of between the two of -2/3. And our interval will be -infinity to -11/3, union -3 to infinity. All right. So now it could be either one, right? Less than or greater than. You have to take a look at it and decide. It doesn't tell us for sure which way it starts. So we want to add the 9 to isolate the absolute value. So we have 3 plus the absolute value of 3 plus 4x is less than 5. So less than, remember we set that up with the 3 plus 4x in the middle. So it's less than 5 and it's greater than negative 5. We then solve, so subtract 3. And I subtracted 3 on all the parts this time. 5 minus 3 is 2. And then we divide everything by 4. And when I say everything, I mean all 3 parts. So we end up with this inequality. Negative 2 is less than x, and that's less than 2/4 would be 1/2. And so we have that one ready to go on the graphing. This is going to be from negative 2 to 1/2. And that's how our interval will also look. Negative 2 to positive 1/2. Okay, this is our last inequality. It's greater than. Okay, so we're going to set this up twice. And I'm going to write this then as 3/4 x minus 1 is less than negative 2. Remember, I have to switch both the inequality and the sign of that number. Or 3/4 x minus 1 is greater than or equal to positive 2. All right, so I'm going to go ahead and add the 1 before I do anything with this fraction. So negative 2 plus 1 is negative 1. Add the 1. I get ahead of myself. I'm doing that again. And 3/4 x is greater than or equal to 3. And then we solve by multiplying by the reciprocal. I need my x in there. I guess this is the day for doing silly stuff. And multiply by the reciprocal of 4/3. Remember, when we multiply a number times its reciprocal, it always equals 1. So that helps us solve this inequality. And so on the left-hand side, I just get 1x is less than or equal to negative 4/3. And then on the other side, I'm going to solve the same way, multiply by 4/3. And that means, right, I can eliminate those 3's. So x is greater than or equal to 4. Okay, so on the graph, it's going to be from negative 4/3, right? It's less than, x is less than or equal to negative 4/3, or greater than or equal to 4. Well, I didn't even use my line. And so we have a union on this one from negative infinity to negative 4/3. Remember, infinities always get a parenthesis. Union 4 to infinity. Okay, and so that is the end of this lesson.